Hey everybody, Vade here, back again with another geometry you need for calculus video, and this video is a little different because I actually created the problem in a way. Well, sort of. I took inspiration from a common calculus geometry application problem known as a related rates problem. So alongside optimization, there's related rates and other stuff as well. But for differential calculus, you will see a lot of optimization related rates problems, and differential calculus is like the start of calculus. So I want to prepare you guys for that first. So I took I think this is like a past like AP question. I'm not 100% sure. And what I did was I essentially took out all the calculus related stuff from this problem, and I'm just like asking, like the purpose of this is to find relationships, like geometric relationships, because the calculus in these types of problems is not necessarily the difficult part. It's more about like taking the stuff that you are given, drawing pictures because it's like a geometry type problem, and then like once you find relationships from those pictures, again, pictures are your friends. Pictures are your friend in both in all of these application problems, especially when you get into calculus. So we got to get into those habits of drawing the picture, interpreting the given info, and finding geometric relationships. So it's really like find a relationship between the height and the radius of the water and the height and the radius of the container. We're gonna read this problem in just a second, but it's sort of like I said, find a relationship. Okay, now this of course is part of the calculus related rates problem that you will be doing once you learn calculus. In fact, it won't even tell you find a relationship. It's just assumed that you will find a relationship. But in fact, I'm trying to like get you guys to do these types of problems before even starting calculus. So I'm trying to like you know, do as much as I can with the stuff that you already know. So this requires no calculus. It just requires some geometry and drawing pictures and stuff that you will, do once you are doing calculus. I'm just preparing you for that because this is often difficult, but the difficult part can actually be learned even before doing the calculus. The calculus is not necessarily difficult. It's more about actually the application itself. So, yeah, let's get started now. A cone-shaped container has a radius of 3 feet at the top, and its height is 8 feet. If water flows through a container with rates of change for both the radius and the height of the water, you would need calculus to even interpret them, so I'm just not going to be giving them to you guys. I think it's kind of irrelevant for like finding the relationship. Because the relationship is completely possible to do without them. Find a relationship between the height and the radius of the water and the height and the radius of the container. So let's draw a picture. And again, like a picture is not given to us, okay? Often for related rates types problems, optimization, you're more likely to get a picture. Again, not always, but in related rates, you're not usually given a picture at all. So it's saying, it's a cone container. It's saying 3 feet radius at the top, so it's going to be like an upside down cone. So it'll look something like this. Okay, this is a decent picture. And it has a radius of 3 feet at the top, so it's going to look something like this. 3 feet. And the height of the cone is 8 feet. So we need to find a relationship between the height and the radius of the water itself and the height and the radius of the container. So water is flowing through this container. So like assume we have like some bucket and it's pouring some water, and the water is flowing as such. It's flowing like this. Okay, so as the water is flowing, it's flowing inside of this container. In fact, I'm going to draw a better picture. Let's say like at this instance, this is what the water looks like. Okay, let's just pick some random instance here. Okay, now we're not given rates of change, because if we were given rates of change, then we would have to like interpret it, and that's in like a calculus context. So we're just not going to do that. But let's just pick some random instance here. Okay, pick any instance. Let's let the height of the water equal to h. I'm gonna I'm going to let the height of the water equal to h. And I'm going to let the radius of the water equal to r. So hopefully you realize, using your knowledge of geometry, this is a similar triangles problem. The ratio of this side to this side is equal to the ratio of h to 8 is equal to the ratio of r to 3. So it'll just be h over 8 equals to r over 3, and that's your answer. Okay, so this is a relationship between the height and the radius of the water, as denoted as h and r, because it's any instance, so there's infinitely many instances you can choose. So I just said h and r can denote those infinitely many instances, but we know that this itself, like this height and this radius, will form a triangle. So then we know that since we're dealing with the same container and it's in the same shape, that same cone shape, it'll be the ratio of the sides will be the same, similar triangles. So there's this triangle here. I'm going to use red here. There's this big triangle here, and then there's this smaller triangle here, but it's inside that same vessel. So the ratio of the height of the water to the height of the vessel or the container, and then is the same as the ratio of the radius of the container, the radius of the water to the radius of the container. So this is the relationship that I was looking for. Again, this is like using your knowledge of geometry, drawing pictures. This is what I'm looking. This is what calculus. This is what the application. This is the hard part of the application, I would say. Finding relationships, finding, or interpreting stuff. So that's why I'm trying to prepare you guys for that. And I'm taking real calculus problems and I'm modifying them for just the stuff that you guys are able to do. But luckily, the stuff that you guys are already able to do is the hard stuff in those problems. So yeah, see you guys in the next one.